So today our lesson is talking about how can we convert AC to DC, why we need it. Most of us now are working on laptop. When you are working on laptop, we use the batteries, and the batteries is working now on DC. But when you want to charge your laptop, you use the charger, you put it on the wall socket. So now your laptop is not working on batteries, it will work now on the current that's coming from the wall socket. So now this thinks that, so before you use the charger, you were working on DC, but when you use the charger, you are working on AC. What's the laptop? How can the laptop work? The laptop before it was working on DC, on batteries. After the charger is working, or after you use the charger, you are working now on AC. So now this black box that is on charger, this is have a converter. This converter, we call it transformer. It transforms an AC to DC. It takes the AC from the wall socket, it transforms it to an DC. That's make the laptop work on it. So here now, let's see how this transformer works. Now, as we say, the current in your home is AC, and the current in a battery operated, such as laptop, cell phone, is DC. So now, when an AC-DC converter, you can operate a battery run device on AC instead of batteries, as I told you. Is it clear when we use AC to DC converter?
Yes, teacher.
Yes.
Okay, let's see now how it's works. A converter uses, to convert an AC to DC, we have to use something we call it transformer. In electrical, we have reflector, we have also transformer. In physics, in grade 11 here, we have to focus on the transformer. The transformer is used to lower the voltage. That's mean in our home, we have 240 volts. But my laptop is working on 12 volts. So how can I convert 240 volts to a 12 volt by the transformer? The transformer, his job is to lower the voltage. And also they use a diode. So they use a transformer that's lower the voltage, and they use the diode to allow electron flow in one direction. This is, but it's not with you, just to take an information. This is the diode. This diode that's telling me that the current must flow on this direction. If it is like this, if they are putting like this, sorry, that means the current will flow to the left. So to convert an AC to DC, I need two things: the transformer to lower the voltage, and the diode to make like a street, like you say, like to allow the electrons to flow in one direction. So how can we convert a 22 volt alternating current to a DC 12 volt? By using the transformer, as I told you. This is the transformer, which is a device that is used to either raise or lower voltage in an electrical circuit. For example, transformer lower the voltage 220 AC to 12 DC volt. So the transformer is a device used to lower the voltage in the electric circuit. This transformer is 12 volt because we want to lower voltage at least 12 volt for DC load required. This is not important. The important here, that is the transformer and its job here is to lower or to raise the voltage from 240 volt to 12 DC volt. To change from AC to DC to lower the voltage from 240 to 12 volt. Is it clear?
Yes.
Okay. Now, the alternating current, as we said before, this is the alternating current. It has two directions. So the alternating current vibrates in two directions. But as what I told you that the diode makes or allow them to walk in one direction. So to allow them to walk in one direction, so we will have a cycle. What does it mean? That's mean this will not working now. It will be converted to be like this. I'll repeat. I told you now that the AC is working like sinusoidal. Cosine and sine. This is a sine. The diode, when it is getting in a diode like this, the diode tell them that you have to, I allow you to work in only one direction. So what we have to do, they will, in electrical engineering, we only choose the first half. So we will clear this one here. So only we took the half of the waves. Sorry, I don't know what's happening here. This is the first step. So the DC here, the diode here, it will half the waves. This is the first step. Then after that, to maintain continuous current while smoothing the pumps, we have to use the capacitor. So first of all, we have transformer. Transformer here, here we have an Here we have an AC, which is an alternating current. This alternating current now is getting into transformer. This transformer here in our home, as we say, we have 22 or 24 volts. This 240 volts is getting into the transformer. This transformer now is make them to 12 volts, but it's 12 volts AC. It is still AC. Then this current now is coming into diode. When it's entering into diodes, we have two diodes like this. I think they are drawn like this. Then they are converting them to DC. So now, when it's the current now is going or is passing through the diode to changing to DC, it's allowed them to pass only in one direction, as I told you. So it was before an AC. It's allowed them to go in only one direction. So to allow them in one direction, you have to cancel or to choose the first half. Then, so after the transformer, then the diode, then we have the capacitor. This capacitor here, that if you charge and discharge the capacitor, it's make like a smoothing continuous waves. This smoothing continuous waves, if it is continue, it comes like an AC and DC. Or the direct current. So here we have transformer. that's changed the current from AC or from 220 to 12 volts, then after the transformer, it's getting inside a diode. The diodes, it's allowed them to go in one direction. So as we see, we have this one here. After that, after charging and discharging the capacitor, we use the capacitor to continuous them to move in one direction. So it can to move like this. So we convert them from an AC to DC current. Is it clear?
Yes,
Yes,
teacher.
teacher.
So let's see here what happened. At A here, when input to a diode is AC, as you saw before, output is pulsating to DC after it's entering by the diode here. The diodes, it's allowed them to go in. So here we have an AC, it's input to the diode. After that, it's allowed them to go in one direction. So it's let them, we have the half of the waves. Then we have to use the capacitor. The capacitor, that's after charging and discharging, it's to provide continuous current. Add D here. To then, in practice, a pair of diodes is used, so there are no gaps in current. If you come back here, as we see, we have two pair of diodes. This two pair of diodes that they talk the first half, then they talk, but this is not important for you, but I will tell you what happened. They take this half, they convert, they change them up here, the second diode, so they make them to work on a continuous current. Here, I will repeat, but it's not important, okay? Here we have this one. As I told you, we have a diode, so we get the first of the upper half. Then there's another diode. The another diode now will take the lower half and they make them up. So then the capacitor will come. So two diodes are working. They make them like this, are working on a continuous, smoother current. So after charging and discharging them, we get them now as an DC current. So here, this is, we said what are the examples of AC and DC. How can or why we need to convert them from AC to DC. Now, by the way, there's another type. There's sometimes you need to convert DC to AC. Sometimes you need to convert an AC to AC. We have many types of converters, but one of them here, which is the transformer, that we need to lower the voltage. So to convert an AC to DC, we need diodes, transformer, and capacitor. The transformer to lower the voltage, the diodes to allow the electrons to flow in one direction, and the capacitor here to give you a continuous and smooth current. By this way, we can convert an AC to DC current, or an alternating, to direct current. Is it clear?
Yes, teacher.
Do you have any question?
No.
Okay. So I will stop here now.